Hello everyone, myself Dr. NCH Ramgopal, working as Associate Professor in Mathematics in the Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. I welcome you all to today's presentation on rank correlation, Part 2. In the last session, we have calculated the rank correlation coefficient R when the values are not repeated. In that case, we use the formula rho equal to 1 minus 6 sigma d square by n into n square minus 1. Here sigma d square is the sum of the squares of differences between the ranks. So, in rank correlation, we assign rank to each and every value and we find the difference between the ranks, and then we calculate the rank correlation coefficient denoted by rho. And this formula is the Spearman's rank correlation coefficient. And now, in today's presentation, I am going to find the Spearman's rank correlation coefficient for repeated values. So, if some of the values are repeated, then how to assign the rank and how to find the rank correlation coefficient, that we are going to discuss in today's presentation. If values are repeated, then we assign the average rank for those repeated values. So, the main point is we assign average rank to the repeated values. That means for repeated values, the main point is a common rank will be assigned. So, for example, if x is having 92, 86, 74, 86, 45, and how many values are there? Total 5 values. Now, while assigning the rank, in general we assign rank 1 to the highest value. So, 92 rank 1, then 86 is a repeated value. So, the next two ranks 2, 3, find the average of these two, which is 2.5. So, assign 2.5 rank to both values of 86. So, that means the repeated values are having common rank. So, now 1, 2, 3 are over. Now, 74 4th rank, 45 5th rank. So, like this we assign ranks to the repeated values. So, the repeated values will have common rank, and that common rank is the average rank. And let us use the Spearman's rank correlation method to find the correlation coefficient for repeated values. So, the rank correlation coefficient is denoted by rho and is given by 1 minus 6 into sigma d square plus 1 by 12 into m1 cube minus m1 plus 1 by 12 into m2 cube minus m2 plus so on. So, here m1, m2 etc. are the number of times a particular rank is repeated. For example, here 86 is repeated 2 times. So, m1 equal to 2. And if 74 is repeated 3 times, then m2 will be 3. Like that, if a particular rank is repeated m1 number of times, so substitute that m1 here. Another rank is repeated m2 number of times, substitute here, and so on by n into n square minus 1. So, we use a different formula to find the Spearman's rank correlation coefficient when the values are repeated. Here rho is the rank correlation coefficient, d is the difference between the ranks, d square sum of the squares of differences between two ranks, total number of values is capital N, and this mi, number of times a particular rank is repeated. So, as an example, here m1 is 2, m2 is 3 and so on. Let us solve one problem so that we can understand the concept here. Calculate the rank correlation coefficient for the following data. Here x values are given in the first row, y values in the second row. Total number of values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, total number of values given capital N is 10. And in that, in x values, small x values, you can see 48 is non-repeated value, 33 again non-repeated, 40 non-repeated, 9, here 16 is repeated 3 times. So, if a particular value is repeated, then we cannot use the first formula to find the rank correlation coefficient. We use the previous one, rho equal to 1 minus 6 into sigma d square in terms of M1, M2, M3 and so on. If the values are repeated, use this particular formula. So here 16 is repeated 3 times. Similarly, in y values, 13 is repeated and 24 not repeated, 6, 15, 4, 20, 9, 6 is repeated again. So 13 2 times, 6 2 times. So 16 3 times. The value 16 is repeated 3 times. In y values, 13 is repeated twice and 6 is also. So in that formula, we have to consider M1 equal to 3 because this 16 is a repeated value and we assign a common rank to that repeated value. So that rank will be repeated 3 times. Similarly, M2 is 2, M3 is 2. And how to assign the ranks? Just now we discussed, we have to assign the common rank to the repeated value. How we get the common rank? By finding the average rank of the repeated values. That let us construct a table to assign the ranks and find the required values. So here, coming to x values, 48, 33, 40, 9, 16 and so on. First, assign ranks to each and every observation. So here the highest one is 65, I am going to assign rank 1. After that, 57 is the next highest, rank 2. Then 48, rank 3. And then 40, rank 4. After that, 33, rank 5. Then 24, rank 6. Now next value is 16. This 16 is repeated 3 times. Actually, how many ranks are completed or finished here? 6 ranks are over. Now the next 3 ranks are 7, 8 and 9. But if we assign 7, 8, 9, these are not the common ranks for the repeated value. A repeated value must have a common rank. So let us consider the average of these two, 7, 8, 9. The average is 8. So I am going to assign the average rank to the repeated value. So now 7, 8, 9 are over. Last rank is 10 and for that here we have the number 9. So like this we assign the ranks for repeated values. Now coming to y values, the highest one is 24, rank 1, then 20, rank 2, then 19, rank 3, and then 15, rank 4, then 13, repeated 2 times. Already 4 ranks are over, now 5 and 6. So the average is 5.5. I am going to assign the rank 5.5 here and 5.5 here. Now 5, 6, up to 6 ranks are over. Now next number is, and the next number is 9. So already 6 ranks are over. So this is 7. And next number 6 is repeated twice. So the next 2 ranks are 8, 9. The average is 8.5. So I am going to assign the rank 8.5 to the repeated value 6. So 8, 9 over. So the last rank is 10 for number 4. So like this we assign the ranks in the case of repeated values. Now find the difference between these two. So 3 minus 5.5 minus 2.5, 5 minus 5.5 minus 0.5, 4 minus 1, 3. Like that we can find the difference between these two ranks. That means the difference between the values of column 2 and column 4. After that, square the values. So 2.5 whole square. And as this is the square of d, we will get all positive values. And this is the final total. Sigma d square is 41. Now coming to the formula, Spearman's rank correlation coefficient when the values are repeated or ranks are repeated. We use the formula sigma equal to 1 minus 6 into sigma d square. 6 into sigma d square plus 1 by 12 into m1 cube minus m1 plus 1 by 12 into m1 cube minus m1 plus 1 by 12 into m2 cube minus m2 plus 1 by 12 into m3 cube minus m3 divided by m into n square minus 1. So, once again go back and check the formula. 1 minus 6 into sigma d square 1 by plus 1 by 12 into m1 cube minus m1. Like that, how many values are there in the given problem? m1, m2, m3. 3 values are there. So, let us write up to m3 cube minus m3. And substituting all these values, 1 minus 6 into sigma d square is 41 plus 1 by 12 into m1 cube is 3. This particular value is repeated 3 times, 16 is repeated 3 times. So, the common rank given is 8. So, 3 times it is repeated. Don't use the rank which is repeated. How many times a rank is repeated, that is m1. So, 3 times 3 cube minus 3 plus 1 by 12 into, in the y values 13 is repeated 2 times. So, 2 cube minus 2 plus 1 by 12 into 6 is repeated 2 times. 2 cube minus 2. N is 10 into 10 square minus 1. So, by simplifying this, we get the final answer as 0.733. Therefore, the rank correlation coefficient between the given values is 0.733. So, in the case of repeated values, assign a common rank to the repeated values by finding the average of the ranks of the repeated values. Let us solve one more problem. In the second problem, the differences between the ranks are given. The differences are given. Also, the sum of m into m square minus 1 by 12, that is also given as 3.5, and rank correlation coefficient is given as 0.44. Find the number of terms. So, we need to calculate capital N. How many terms are given? So, for that, using the differences, we can calculate sigma d square and use the formula 1 minus 6 into sigma d square minus this value for repeated values 3.5 divided by n into n square minus 1. And here given rho is 0.44. So, we can substitute that here 0.44, 1 minus 6 into this sigma d square can be calculated by squaring and adding these values minus 3.5 by n cube minus n. And after simplifying this, we get capital N equal to 42. So, total number of values are given as 42. So, using the rank correlation coefficient, we can find the number of values if row value is known. Similarly, if all the remaining data is given, we can find rho in 2 different cases when the values or ranks are repeated and not repeated. And this problem is given to students for practice purpose. And here first you have to identify whether the values are repeated or not. If the values are repeated, use the previous formula. Otherwise, we use the first one, 1 minus 6 sigma d square by n into n square minus 1. Now, coming to x values, here the 68 is repeated twice, 68 2 times, then 67 is repeated 2 times. Now, to assign the ranks, the top one 71 first rank, 70 second rank, 69 third rank. Now, 68 is repeated twice. So, 4th and 5th ranks are shared to this repeated value. So, average rank is 4.5. So, 5 ranks are over. Next, 67 is repeated twice. So, 4, 5 over, then 6 and 7, 6.5 here, 6.5 here, 7 ranks are over. Then 66 8th rank, 65 9th rank, 64 10th rank, 11th and 12th. Like this we assign the ranks to the repeated values. Similarly, coming to Y values, again 68 here, 1, 2, 3, 4 times repeated, and then 66 1, 2 times repeated, and 65 is again 65 also, again 2 times, and all the remaining values are non-repeated values. So the top one is 71. So assign the rank 1, then 70 rank 2, 69 rank 3, then 68 rank 4, 5, 6, 7. So 68 is repeated 4 times. So we have to give the common rank for the value of 68 and the average of these two. So 10 plus 12, 22 by 4, 5.5. So this is 5.5, 5.5, again 5.5 and 5.5. Total 7 ranks are over. Now 8th rank goes to 67 and then 66 2 times. So 9th and 10th ranks, 9.5, 9.5. So 10 ranks are over. And 65 is the last, 11 and 12th rank, but 65 is also a repeated one. So 11.5 here, 11.5 here. Now use the formula to find the rank correlation coefficient. 1 minus 6 into sigma d square plus 1 by 12 into m1 cube minus m1 plus so on by n into n square minus 1. So here m1 in x value 68 is repeated 2 times. So m1 is 2, m2 67 is repeated 2 times, m3 68 4 times, m4 66 2 times, m5 65 2 times. So substitute all these values and find the sum of the squares of differences, and that gives the rank correlation coefficient. This is for today's session and we will meet in the next session. Thank you.